Last time on DataBard, we were able to successfully replicate our pattern, moving it from one target table to another target table and getting that second table to process successfully. But as my kids' Odd Squad episodes taught me, a pattern isn't just a pattern if you do it once. The pattern has to replicate at least twice to be a successful pattern. So we're going to try and replicate this pattern a couple of more times to make sure there are no flukes on today's chapter of DataBard. DataBard, 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 DataBard. Dabba 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 dabba, hoi hoi hoi. Let's pick up where we left off and end on a high note. So last time, when we were working with creating the store procedure for dim region, took like 3 or 4 prompts to finally get one that really generated the pattern the way we wanted to, making sure it could adjust for type 1 to type 2 changes, differences in columns, and making sure that it caught all of the columns in the table. But the real goal here is the next step here, which is where hopefully we're able to find that making the second copy of the pattern is easier because the first one figured out the problems. Let's see if that's the case using products as an example. So I'm going to bring up the last prompt that we had. And I'm going to make adjustments to it to allow us to process products instead. So take a look at our base for the pattern that loads data from explains the same thing that we're doing. Using the same pattern, create a new store procedure that loads data from dbo.products into stage.products and then into dim.products. Let's see, dim product type 1, which I believe it is. I don't think we added in anything here that lets us do... Oh, no, it is type 2. So we do want this to copy type 2. Dim products is a type 2 SCD table, so any logic that implements type 2 evolution can remain. Make sure that your logic, and this is where there are a couple things specific to that. Let's check our product design. It does calculate hash value. So we need the hash value. And let's see if we can simplify this. Make sure that your logic includes processing all business columns, especially when they are not null. No, I wanted to make sure... No, I'm going to rewrite this section. And be sure to populate at least every column in dim products that is not null. Take a last look at that, and I feel like that's a good initial pass at that. So hopefully we get this on the first one. In which case, this might be a short video. Alright. Go, Copilot, go! Here we go. Alright, let's initially take a look at things. Made the hash bytes for product. Okay, there it inserted the whole thing. All right, let's take a quick look at this. Do an initial check. Again, AI, we need to assume that it could possibly be wrong, which means we need to check it. Store procedure, truncate table. So it's going to clear things out. That's good. Batch identifier, it's been keeping that consistent. In terms of inserting into products, we start with the stage table, which is the source key, product ID, product name, category, price, stock quantity, effective start date, effective end date, inserted date, updated date, ETL batch ID, hash value. I think that captures everything. Most of the data is there. Get date, appropriate for getting those values, hash bytes. Alright, then merge statement. We know it's a type 2, which means it needs to check is current equal to 1. It did that on the merge statement. Good there. When matched and checking if the business columns are different, then it expires it. When not matched by target, then insert values. Good there. So for the most part, the pattern looks pretty good. The merge statement is what it's been consistently generating for us, but it's also maintaining the same bug that we've been running into when merging things. Is it's assuming that this is going to capture new versions of the record, which is not what it should. So we're getting a consistent response there, and maybe this is where long term, if we consistently run into this issue, what should we be doing? If we're heavily wanting to use something like SSMS Copilot to do our dev work, that's where we need to make that difficult choice. Do we keep our pattern the way that it is and still struggle with the Copilot, and we can figure out some ways to work with it in terms of prompting? Or do we maybe need to redesign our pattern into something that makes more sense for the way the Copilot is interacting? My guess is that it's confused about the merge statement and the full scope of what it does. Probably what I'll do at some point, not in this video, but in the future, is testing what does this pattern look like if we change that merge statement into a set of update and insert statements to reduce the complexity. My hypothesis is I think the SSMS Copilot will have a better job understanding the pattern that way than it does with the merge statement. So we'll give it at least a second prompt for this. So write a query that inserts data from stg.products into dim products, but only when the product ID, I believe, is our... Yes, that is it. Only when the product ID matches between the stage... between the two tables. Yes, I know. Okay. We'll insert that in. Clean up the formatting a little bit. And this pattern is probably going to need some extra fine-tuning for sake of actual production situations, because it just assumes that if this staging record exists and the production, if the staging table has a record, production also has that record, it's just going to insert it in. What we really wanted to do is we wanted to do that, but we still only want to do it when we detect that changes have occurred. Which actually, we should be able to copy the predicate up here, now that I think about that. This code isn't going to be 100% pretty, but humor me on it. Oh gosh. We go dim, then SDG. SDG. Alright, not exactly a major adjustment, so doing it with a Copilot doesn't exactly save us a whole lot of extra time. And then we finally get the metrics for the run log. I just noticed here that it marks it in progress and then immediately completes it in the following statement. Probably something else we would fix in this pattern long term. Alright, I think that's good for an initial go. Let's see. So I'll double check products. I don't believe we've processed yet. Correct, we have not. Let's see if we can get this. Exec. Command completed successfully. And there's our data. Process, nice and pretty. Everything's populated. Alright, had to write that second prompt. To add in the extra section there for what it's been consistently emitting, but still 10 minutes and we wrote an entire ETL procedure for the next one. Now let's get our last table, which is our fact table. And this is where the prompt is probably going to take a little bit more work to fix. So this loads data into employees and blah 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 using the same pattern created per procedure that loads from, and we're working on sales transactions now. So sales transactions. Into the staging table for sales transactions. And I hit the button again. I really need to stop doing that. So sales transactions into sales transactions Oh, and actually that's not the right change I need to make. This has to also be fact because it becomes a fact. Use this, we need to completely rewrite fact. Sales transactions. And this is where we need to describe it as a fact table. Should be removed. Assume that incoming records may have updates to sales transactions. Existing sales transactions So make sure to update the existing record, the incoming values when possible. I think at least we want that. Let's double check our definition of the fact table. So for the most part, it's our surrogate key, natural key, data of the transaction, foreign key relationships, quantity, total amount, and it does include inserts and updates. So we do want it to perform updates. Make sure that your logic includes processing all, making sure to populate at least every column in the fact table. Trying to simplify this so that we can theoretically template this later. See, and then we talk about hash value. Did we have a hash value on sales transactions? We did. The staging table. The more we can template this, the more we get ourselves to a point where ideally we save off this template prompt, and then anytime we need to create a new table, we create the table structures, which we could also template some prompting for that as well, and then this generates the ETL process. The last thing I want to make sure I call out is going back to our fact table. We've got these couple foreign key relationships. So far, copying the pattern hasn't had to create a foreign key relationship. That's only in the base pattern. So we want to make sure we call that out for any foreign key columns. Write a statement. Perform a lookup to the target table and find the appropriate primary key value. If the lookup fails, give the... Oh, and actually this is going to fail for some of these tables because they don't have their own records yet. If the lookup fails, give the records the how do I want to write this? Foreign key column value of -1. Right, we've accounted for the fact that this is a fact table. We've accounted for the fact that it's going to need to do foreign key lookups. We've calculated the hash value and making sure that it's not going to do SED type 2 evolution. Let's see how well it can copy from a dimension template into a fact template. Because ideally, we would have just one pattern. I suppose if we needed to have a pattern for dimensions and a pattern for facts, that's not the worst case. You're at least dealing then with two patterns, but one would at least be simpler for future use. Alright, process sales transactions, truncate the staging table, batch ID is looking good. And then we insert into the staging table. Oh, there, it generated the whole thing. Let's insert that in. So we have some more room to take a look. Yeah. Bigger text. Inserting into the staging table. This is where it's doing the foreign key lookups. Is null. So it's got an is null constraint, -1. It caught that. Good. Select product key where product ID equal to DBL sales transactions product ID. Alright, at least that matches the pattern of what we did in our base query, so that's good. Quantity total amount calculates the hash bytes. Now let's double check here. Change type. It is accounting for all the columns as far as I can see from an initial scan. Merge statement, it's maintaining that. It removed the is current constraint, which is good. This is fact table like this, since we're allowing future incoming records to update the existing ones, means it's essentially a type 1 for most intents and purposes. And it's updating the values good. When not matched, insert the value. And in this case, we're not doing any expiration, so that works well. Alright, regions, we didn't get it where it's successfully generated and processed. Let's see if it works this time. Exec. Set up our test. And let's check our fact table to make sure that it does not have any data in it. It does not. Let's run this. This probably actually isn't going to work. I'm expecting it might hit some unknowns, and if it hits unknowns, we're going to get errors on that lookup. Let's see if we get it. It's still doing the same thing it was on the previous prompts, which means it is looking for a error log table that does not exist under that name. Now, at least an important point about that I could probably fix with another prompt that calls this out in the chat window and says that this is a consistent error that it's making sure to do that update. Let's at least do that. This will be a quick side test. You're consistently making an error referencing a table called stg.errorlog. This does not exist, and the table name you're looking for is stg.etl_errorlog. Regenerate the stored procedure for fact.sales transactions as above, but fix this error. We'll let that run. Let's rerun our process while that's going on. Subquery returned more than one value. Ah! So what our pattern is missing is it is missing that dim employee has evolved. Right now there are 2 versions of every employee there. Our lookup doesn't account for that. We need to fix our prompt there. But first, let's at least check our previous one. There we go. It got the ETL error log right there. That's what we wanted to see. Now it's actually referencing a table that exists. I'm curious, did it apologize for that? Nope. Sorry, SSMS Copilot does not apologize. That's alright. Politeness is just waste of tokens. So if the lookup fails, get up according to you. Make sure the lookup checks if the target table is a SCD type 2 table, and if so, adjust the lookup to find the current version of the record. So we're assuming for sake of this pattern that when our fact table needs to look up to it, because of the dates that we have available, you have two paths. Either one, you always have your facts looking up to the current version of the dimension table, or you try having it look at what was the effective state of the record at the time this transaction occurred. I'm choosing first pattern because I expect at least doing is current is going to be more consistent. Although actually now I'm challenging myself on that. Alright, first let's see what it generated here. Actually, let's check. It caught the update in the generation here, so that's good. Let's insert this in. So there we go. Product ID evolves, so it's checking for is current. Employee evolves, so it's checking for is current. Region does not evolve, and it adopted that pattern. One also important thing I want to note here, and this is something that some people have raised as concerns as I've been doing this experience, is you're dealing with generative AI, so things aren't necessarily deterministic. What we've been consistently seeing here in terms of the experiments is once it generates something, if I'm not asking it to make an adjustment, it's not adjusting it. So I am actually getting more of a deterministic experience even from something that is generative. It's listening to what I want it to do and only doing what I ask it to do. That looks much better. Adjust that to an alter. Let's test it. Cannot insert for identity column. What table is set as the identity? It's set to off. Where are we inserting? Would not be our fact table, because our fact table we don't have any of those constraints built in. Oh, here it is. Okay, so this is the issue. Here in the merge statement, when it's inserting a brand new record, it is inserting into the transaction key, which is, yeah, that doesn't make sense. So let's add in do not insert any values into identity columns. Let's get rid of that. And there we go. It no longer is inserting into transaction key. That should fix that issue. Let's make sure it kept our other recent changes. stg.etl error log. It's been keeping that naming convention. The foreign key lookups still remain looking good. It is maintaining. No, it is not maintaining that. Did I give it a wrong? Oh, I think I gave it the wrong prompt. Yep, I gave it the wrong version. Because I removed that, that's why it got that out. Do not insert any values into identity columns. This is the version that we're going to want. Probably. Alright, that's in there. Make sure it fixed that issue. Yep, that is back. Good. Now we check when not matched. Transaction ID, good. Or that transaction key is missing, that's what we wanted to check there. Stage ETL error log maintains there. Alright, let's run another test. Command completed successfully. And look at that. Let's remove the top. There. 5,000, and take a look at that. Employee keys are visible. Product keys. We got region keys in here. Inserted date, we inserted everything once. We have data. And now we can process all of our tables. Yay! Alright, so let's recap. In the span of the past couple of videos here, taking our initial pattern and replicating it to use it on other tables, we've been able to replicate it with a little bit of extra work into 3 separate tables in the span of about 45 minutes. I don't know about you, but at least even for me, when I've worked in pattern-based implementations, to be able to copy a pattern from one place to another, something like this, if I were to type it out by hand, hours of work easily per table. Just to write the code. Here, we're able to do 3 tables in 45 minutes. That's about 15 minutes per table. That's a huge time savings. And granted, this situation is simple. It's not as complicated as a lot of the scenarios you would run into in the actual world of data. But it's at least a good place to write that base pattern across the board, and then your time refocused on dealing with those adjustments that are needed versus having to write all that code by hand. I mean, how many times do you really benefit from writing, oh, I want to check when this column doesn't equal this column, this, that, and the other thing, on to do the same thing on a hash? You don't want to have to spend the time of that. You want to spend your time on where you provide benefit that AI can't, and that's understanding business rules. This demo, honestly, when I initially created this series, this was what I was targeting, was being able to do this type of replication. And did SSMS Copilot do it? It knocked my expectations out of the water. This is even better than I expected it to be initially. And if you do pattern-based development, this is something you should take a look at too. I guarantee this will save you time for this approach. Would I do this over using Copilot to create a pattern? I think yes. What I think this, at least one lesson learned from this experiment, is that Copilot understands a number of things about ETL patterns. It understands some principles of Kimball. Is it able to come up with a strong, effective pattern for it? Not without a lot of extra guidance. But since AI is all about patterns and pattern recognition, using it for recognizing a pattern you give it, and then being able to copy that with certain adjustments and such in play, It's almost like it was made for this specifically. We should expect it to do well here because it's just following a pattern. In short, if you're looking to get into AI-driven development and you're not sure where else to go with it, this is a great example. Give it a code sample, see if it can replicate it with a couple of adjustments that you do in terms of prompt writing. And if you want to get super fancy with it, which I'm looking to do, is creating a library of prompts that can do this sort of thing on a consistent basis. That brings us to the end of this video. Hopefully this really showcases where SSMS Copilot can really change the way you do your work. What do we need to do here? If we like this stuff, and hopefully you do, like button is down here, the subscribe button down here somewhere as well. Hit those buttons and let's keep pushing the limits of vibe coding in a responsible way. Because again, I did not accept anything that I did not trust. I did not commit things unless I understood the code. At least the majority of it. There's still a couple of bugs that we need to work out, but I'll be researching that after I record this. So if this video helps you, again, hit that like button, subscribe to the channel. We're going to be doing more of this. If there are other scenarios you want me to test with a Copilot experience, let me know. This is what I'm here for, is to test this out. And that's what the series is all about. If there are other scenarios you want to see, I'm repeating myself. For now, I'm DataBard and I'll see you in the next chapter. Today's chapter may be done, but that doesn't mean the story is over. If you are looking to work with someone like me to improve your data strategy or implementation, go to bakertilly.com/digital, fill out the contact form, and let's see how we can help you take the next step on your data journey.